Okay, just before we take a look at the last examples here, we're going to try simplifying expressions. Okay, so simplifying we've been making our expressions easier by using our exponent rules, but we might also have some other things involved. Maybe there's numbers and letters, or a series of numbers and letters. Okay, so there's a couple of things you need to watch for. Number one, bedmass rules. So if we can't simplify, we have to use bedmass, right? Brackets first. If we see adding, subtracting, bedmass might come into play. Okay. Number two, you have to apply your exponents to things inside the brackets. There may be more than one part. There might be numbers and letters. Okay. And you have to be careful with operations between numbers. If there's different bases, back to bedmass. Okay. Our exponent rules only work if our bases are the same. So we'll go through a couple of examples to show you what I mean by all this, but just some things to be careful about. Okay, I want to simplify, make my life easier. I look at my bases and say, hey, they're the same, and I'm multiplying. I can use exponent rules, so I'm going to. Bases are the same, multiplying. I can add my exponents. Okay, I'm going to add these up. 5 plus negative 6 gives me negative 1, but we don't want negative exponents. So what do I do with that? I flip it over. Done. That's it. I try B. I see a power to a power here. Okay, that's definitely an exponent rule. I can multiply these ones. And what's going to happen? I'm going to get 5 times negative 1 is negative 5, but I don't like those negative exponents, so I flip it over. All right, C. What do I see here? I see two things in the bracket, and they're different bases. One's a 3, one's an x, so I can't put those together. But I see a power to a power, so I need to apply this 3 to everything inside the bracket. Now, the obvious one is I get x6, right? 2 times 3, I multiply that. But the not so obvious one is I also have to apply the 3 to the 1. 1 times 3 gives me 3 to the 3. And this one, I want to simplify it a little bit, so I could say 3 to the 3 is 27, x6. The reason I would do that this time is because I've got two different bases in there. Okay? The ones prior to that, I only had one base, so I didn't really worry about calculating them, but because I have two different bases, I kind of want to. Yeah, let's take a look at D. What do I need to apply this 2 to? I got to apply it to everything inside the bracket. So I need to get 2 to the 2 and x to the 8 divided by 2 and x to the 3. Well, divided by, I could, if I really wanted to, I could write this out as 2 to the 2 x to the 8 over 2 to the x minus 3. It might be easier to think of it that way to remind myself that if my bases are the same, I'm supposed to subtract my exponents. I can work downwards, think about going straight down the columns. Okay, 2 to the 2 divided by 2 to the 1 makes 2 to the 1. Subtract. Okay, x to the 8 and x to the 3 makes x to the 5. So my best answer here, 2 to the 1 is just like saying 2 is 2x5. And you got to be careful to apply every exponent to the things inside that bracket, right? Okay, let's try E. What do I see with E? Inside the bracket. Can I do anything with that? Not really. They're not the same bases. Okay, I gotta go bedmass rules. Bedmass says let's figure out what the brackets are first. So let's multiply this together. What is 3a3 times 2b4? Well, 3 times 2 makes 6. And since my letters are different, I can't put them together. I literally write them beside each other. Okay, all squared. What do I have to apply that exponent to? Everything inside the bracket. So 6 to the power of 2, a to the power of 6, b to the power of 8. We're multiplying, right? Each one of those. There's a 1 there, don't forget. And how do I simplify this? Well, 6 squared makes 36. And that's as far as I can go with this one because my letters are now different. Different bases, I stop. Okay, letter F. Brackets. What can I do inside the brackets? I can divide 8 by 2. 8 by 4. That gives me 2. And what can I do with my bases if they're the same? Well, the x's are the same bases, so I can subtract my exponents. I still have the 3 on the outside, though, right? Okay, so I did operations with the numbers because I could. I did exponent rules with the letters because they're the same bases. What do I have to apply that 3 to? It's got to apply to that one and that one. So 2 to the 3 and x to the 9. Make sure we're multiplying, right, our exponents. And 2 to the 3 is 8. So 8x9. Okay, and that takes us to the end of this unit. There's some rules in here to be careful about. Give them homework a try, and then try the quiz after that and see where you get to, okay?